See the diagrammatic representation. So this is the austenite phase of SMA, this is the twinned martensite phase of SMA, and this one is the deformed martensite phase of SMA. Then we move on to the types of shape memory alloys. So in SMA we have a one-way shape memory alloy and two-way shape memory alloy. So in one-way shape memory alloy, though there is some change in its temperature, SMA remains in the same phase. So and this type of material is called one-way shape memory alloy. Or when the material is cooled below the martensite ends temperature, then there exists a minor change in the energy inside a material. But the individual atomic units of martensite will self-align in such a way that the material will remain in its martensite form alone. So that kind of material we call it as a one-way shape memory alloy. Then two-way shape memory alloy. So this type of materials which produces spontaneous and reversible transformation just upon heating and cooling, even without the load, are called two-way shape memory alloy. So and also if the temperature is increased, then the martensite becomes austenite, and if the temperature is decreased, so it reverses to its martensite phase. Then we move on to the characteristics and properties of SMA. So regarding the properties, the first one is the shape memory effect. The change of shape of a material at low temperature by loading and regaining of original shape by heating is known as a shape memory effect. So here we will draw the graph versus, that is a load versus a temperature. So this is nothing but the processing of SMA. How the phase transformation will take place during the variation in a temperature. So see the diagram. The first one, that is cooling, is a process 1 and loading is a process 2 and heating is a process 3. So then for the case of first process, when you vary the temperature or undercool the material, the austenite phase, it will transform to become a twinned martensite phase. Then second process is that loading. So in that process we didn't change any temperature, or we need to maintain a constant temperature. So at that stage, if you are applying a small load, then automatically the twinned martensite, it will change into shape by deformed martensite. Then the third process is a heating. So when you are apply the temperature on your, if you are heat the material, the deformed martensite, it will transformed into austenite phase.